We have all been there. You are building a .NET application and suddenly writing dozens of manual SQL queries to keep your data organized. As the application grows, that web of manual queries gets brittle and ultimately collapses under its own weight. On the left is your C# code, and on the right, a relational database. Entity Framework Core is an object relational mapper that translates your code directly into database commands, building a bridge so data flows smoothly without writing the SQL yourself. By the end of this, you will build a functional database schema and write new data to it using nothing but C#. To follow along, you need three things: an open ASP.NET project, the .NET Core SDK installed, and a SQL Server instance. Writing database queries by hand introduces typos and disconnects your application logic from your storage. Automating the translation between your code and your database speeds up development and keeps your data structures perfectly aligned. Step 1 is setting up the environment. Open your project terminal so we can install the foundational framework that handles the translation. This terminal image shows the exact commands you need to run. We are installing 3 specific packages: Microsoft.Entity Framework Core, Microsoft.Entity Framework Core.SQL Server, and Microsoft.Entity Framework Core.Tools. Pay close attention to that last package. If you skip the tools installation, your database generation commands will fail later on. Once those run, check your project file. You should see all 3 packages listed as package references, confirming the installation was successful. Now we define the data model. Create a C# class called Product. This is a simple POCO object. That means it is a basic class with properties like ID, name, and price, containing no complex logic. This diagram illustrates our next step, the app.db context class. Think of the DB context as the primary manager for your data. It takes your standalone product class, envelops it, and prepares it for translation to the external database. Defining your models inside this context is the crucial link. It tells EF Core exactly how a C# object should be structured when it eventually becomes a table in your database. We have the manager, but it needs to know where to send the data. We have to link the app.db context to your SQL Server instance. This IDE mockup shows your application's configuration file. You will register the database context here using services.addDBContext and point it to a specific string called default connection. That connection string safely lives over in your appsettings.json file. Keeping it separated prevents hard-coding typos in your main application logic. Next, we use migrations. Migrations are the mechanism EF Core uses to incrementally update your physical database schema to match your C# models. Before running any commands, save all your C# files. If you do not save, EF Core will generate a completely empty schema. Run the initial migration and database update commands in your terminal. Your C# product model transforms into a structural blueprint, permanently stamped onto your blank database. Inside, you'll find an empty table with column headers perfectly matching your C# model. Using migrations provides strict version control for your database structure. As your application code evolves, your database stays perfectly synchronized. The schema is ready. Our final objective is to prove the integration is live by performing a basic create operation in the database. In your application code, instantiate a new product object. Give it a name like laptop and assign it a price entirely in C#. This split screen shows the final command. On the left, we add the new object to the app.db context and call context.saveChanges. On the right side, the Database Explorer waits for the data. Run your code, then refresh the database view. A new row of data appears, fully populated with the parameters you defined. Abstracting these create, read, update, and delete operations away from raw SQL means you spend less time managing storage mechanics. Your cognitive focus stays entirely on your business logic. We achieved the primary objective. You now have a live C#-driven database connection without writing manual SQL. This checklist summarizes the exact workflow we completed. We installed the necessary packages, configured the context, migrated the schema, and wrote our first data. The logical next steps are reading, updating, and deleting that data. Those operations do not require any new setups. You will use the exact same app.db context and standard LINQ queries. LinkWe is a built-in C# feature that lets you query data using intuitive C# syntax instead of SQL. Mastering EF Core removes database management as an external hurdle. It becomes an integrated, native tool directly within your .NET ecosystem.